This is going to be a tutorial about isotopes. So if you see here, we have our periodic table as we've been learning in class. And the periodic table has something called an atomic number written on top of each symbol. So if you notice, here is hydrogen, and here is its atomic number, which is 1. If you look from left to right on the periodic table, so as you go across the periodic table, the atomic number increases from 1 to 2 to 3 to 4 and so on. Each element has its own atomic number. No two elements have the same atomic number. So, what is the atomic number? I like to think of the atomic number as the element's address. If you have an atomic number of 1, like hydrogen, you are the first element on the periodic table, and so on. An atomic number is represented by the symbol Z. And what an atomic number is it's that element's number of protons. So it's the number of protons that element has inside its nucleus. Both protons and neutrons can be found in the nucleus, and the electrons are found outside the nucleus. Your number of protons define who you are. So each element is defined by how many protons it has. And the periodic table is set up in order of increasing proton number. Your number of protons, so your positive charge, because protons are positive, are equal to the number of electrons you have. So if hydrogen has 1 proton, as we saw above its symbol on the last slide, it also has 1 electron. Because it has 1 positive and 1 negative, and that balances out to 0, we call this a neutral atom. Let's take a look at some other atoms seen down here on the slide. If you notice, we have carbon, silver, and chlorine. Carbon has 6 protons. I can find that by looking at the periodic table. So let's take a look at that now. Did you find carbon? Did you see the number 6 written above it? That stands for its number of protons, which again is the same thing as calling it its atomic number. So an atomic number is the number of protons. How many electrons does carbon have? It also has 6 electrons. Let's do silver. 47 protons because it's element number 47 and 47 electrons. How about chlorine? Hopefully you said 17 protons because it has an atomic number of 17, which means it also has 17 electrons. That's, again, if we're talking about a neutral atom, which so far that's all we know, are neutral atoms. Now let's talk about mass number, which is represented by the letter A. Mass number is how heavy our atom is going to be. So what's important to know is that the atom is made up of the 3 subatomic particles, protons, neutrons, and electrons. Except out of all of those 3, the electrons have such little mass that we basically say their mass is negligible, meaning so little it doesn't really make a contribution. So what's left? Protons and neutrons found in the nucleus. That's where most of the atom's mass is from. So in order to get the mass number, you take your protons and add them to your number of neutrons. So let's take a look at carbon. In the example below, carbon has a mass number of 12. How did I know that? Well, I knew that it had 6 protons and 6 neutrons. So if I add those up, I get 12. Let's take a look at silver. In the chart, it says 108 is silver's mass. How did I get that? Well, I must have been given my protons, which is 47, and my neutrons, which is 61. Now, just to kind of summarize, you can always find your protons on the periodic table. Just find silver and look up its atomic number. As for the neutrons, that was given to you. You have 61 neutrons in this example. So then you add them together and you got your mass number. So let's write a little equation for that. Mass is equal to protons plus neutrons. So now what if I give you the mass? Can you find the number of neutrons? Sure, that's just some algebra. I first look up my protons on the periodic table. So if we were talking about carbon, we would look up our protons and find them to be 6. And let's say I gave you the mass, and that was 12. We'll set n to x. So now if you just subtract 6 from both sides, you know that 6 is your number of neutrons. Now that you have some background information, we can actually move on to the main topic, which is isotopes. Turns out that all the atoms that you see, all the elements you see on the periodic table, they actually have what I like to call twins or triplets of themselves. So if you take a look at something like hydrogen, there's actually a couple different types of hydrogen. And they're all the hydrogen atom. And the reason why we call them all the same hydrogen atom is because what identifies it as hydrogen is its proton number. Hydrogen has 1 proton, and it'll always have 1 proton, no matter what. But there are some hydrogens out there that actually have different number of neutrons. They're still hydrogen because they have 1 proton, but different number of neutrons. So if they have different number of neutrons, but the same proton number, then we call these isotopes. Let's take a look at these definitions and write them in your notes. Isotopes have symbols, meaning a condensed way to express you have an isotope. This is the format you're going to need to know. This is called an isotope symbol. It's also called a nuclear symbol. So if you notice, in the middle right here goes the element's symbol. So carbon, we put a big C in the middle. Hydrogen, we put a big H. Then up on top, on the left-hand side, you put the mass number. On the bottom, you put the atomic number. And here are some reminders about how to get mass and how to get your atomic number in case you forgot. This is called an isotope symbol. Now, since you put the mass on top and the atomic number on the bottom, I like to say this spells out Ma. Not Pa, but Ma. Here's an example of hydrogen's isotope. This is just one of hydrogen's isotope. If you notice, I put the symbol in the middle, the mass number on top, and the atomic number on the bottom, right? Spelling out Ma. Here would be another one of hydrogen's isotope symbol, H, 2, 1. Now, let's look at this picture here of isotopes of hydrogen. So these are all atoms of hydrogen. Okay, this is hydrogen, this is hydrogen, and this is hydrogen. They're all 3 atoms of hydrogen. How did I know that? I focused on how many protons were in the picture. 1 proton, 1 proton, 1 proton. I looked that up on the periodic table and noticed who has 1 proton? Well, that's hydrogen. Your atomic number of 1 tells you how many protons you have. Then I looked to see, now, are these all the similar atoms or different atoms? Are these isotopes or not of hydrogen? If you look here, there's no neutron in the nucleus. If you look here, there's 1 neutron. And if you look here, there's 2 neutrons. So because there's different number of neutrons, this is called an isotope. Notice the electrons stay the same and the protons stay the same. Now, this isotope is called hydrogen. Its other isotopes are also called hydrogen, but sometimes they get different names. Don't worry about the different names. Let's take a look at this isotope chart. If you notice, the isotope symbols are given to you. And from these symbols, we could pull out information. Though at first glance, it doesn't seem so. But we know that mass is on top and atomic numbers on the bottom. So when I filled out the parts of my chart, I knew atomic number is my number of protons. So there's the 1. And then how did I get my electrons and neutrons? Well, remember, protons equal neutrons if you're talking about a neutral atom. So these two equal each other. And how did I get my number of neutrons? Well, my number of neutrons was received from my mass formula. I'm just going to write down here, if you remember, mass is protons plus neutrons. So if I knew my protons were 1, and I got my mass from up here on top, which is 1, set my n to x, and solved, 1 minus 1 gives me the 0. And that's the end of isotopes. And as promised, here are my 2 shout-outs, #Eddie and #Alex. See you guys tomorrow.